just when we were done?
I think so.
All right,
We're not done
so
yet.
quick warm up here. What's the reference angle for 120? 60. You guys are awesome. What's the reference angle for negative 150? 30. Awesome. All right, let's jump down to here. Sine of 60. All right, so think about our 30, 60, we'll just go 60, 30 here. What is opposite to 30 usually? Supposed to know this. 1, hypotenuse. 2, opposite 60. Radical 3. So sine of 60. What's sine? Opposite. Over hypotenuse. Okay? 45. What do we make the sides? 1 and the square root of 2. Good. So tangent of 45. Let's use this bottom right as our reference. 1 over 1, right? Cosine. Number 7. 1 over radical 2, which means we have to do what? We got to rationalize it, right? Cosine of 60. 1 over 2, right? Adjacent over hypotenuse. Okay? Again, I've told you, if you know those two triangles, trig life's simple, right? Okay? All right, so we're going to convert angles between degrees and radians. We already know how to do that, right? We worked on that already this week. We'll review it again. And then we're going to start talking about that unit circle that I showed you a little bit of yesterday. Okay, radians, unit circle. Okay, so when we did our little activity on Monday, remember that the radius R, which are these, this is also an R, right? And that arc length is the same, is an R. All right? So that's how they figured out what a radian was. Okay? So a radian is a unit of angle measure based on arc length. Okay? And recall from last year geometry that an arc is an unbroken part of a circle. If a central angle theta in a circle of radius r, then the measure of theta is defined as 1 radian. Okay? So when this arc length matches the radius of your circle, and we figured that out to be between, it's like 57 point something degrees. Okay? And then we know that the blue arc represents 180 degrees, which is pi. And the red arc was 360, which is 2 pi. Oh, it does say pi over there, right? But 90 degrees is a quarter of the way, that's pi over 2. 270 is 3/4 around, that's 3 pi over 2. Okay? So then what are we going to multiply by to change from degrees to radians? Come on, say it. Pi over 180. When we go from radians to degrees, we multiply by 180 over pi. What's always going to happen to the pi's when we go from radians to degrees? They're going to cancel. Okay? So again, here's what I do. Basically, you're just dividing by 180 and putting pi in your numerator. Okay? So what happens to those zeros? They'll cancel. And then you reduce 6/18 to what? 1/3, right? So they don't put the 1, but if you put the 1, it's okay. Again, this is review stuff, right? We did a little bit. I don't think we did any of that yesterday, but we did it Monday and Tuesday, right? I think there's a B here. All right, so we're multiplying by 180 over pi. the pi's cancel. And then I just think, how many times does 3 go into 18? 6. So 3 into 180, 60, right? And what's 2 times 60? 120. Again, this is review stuff. We did this already Monday and Tuesday. Okay, angles measured in radians are often not labeled with the unit. If an angle measured does not have a degree symbol, you can assume that it's in radians. Sometimes they write radians, but a lot of times they won't. All right, so again, just do pi, 180. You got zeros, get rid of them. 2 goes into that. 4 times 2 goes into that. Yeah, so it's 4 pi over 9. Okay? Here we're doing 180 over pi, so the pi's go away. How many times 9 go into 18? 2, so 9 into 180. 20. What's 2 times 20? 40. Making sense? Harris, put that phone away. Okay, do I need to do this again? Okay. Okay. So you know 9 goes into 180 all the time, right? You know 9 goes into 36, right? How many times? 4. All right, so negative 4 pi. And what did we say? 9 into 180? 20. Oh, whoa. 4 and 20, 4 goes into, right? Yeah. 4 into 4? 4 into 20? 5. So we could go, so it looks like 36 goes into 180 how many times? 5 times, right? This one I shouldn't have to do. What's 2 pi? 360. So what's 4 pi? 720, yeah. Okay. All right, so this 4 times 180, which is 720. Okay. All right, here's that unit circle.
Whoa.
Okay, I didn't show all that stuff on there. I just showed you the X, the Y, and the circle, right?
Wow.
How far is it from the center to the edge? 1. The hypotenuse is always 1 on the unit circle. Okay? We're only going to worry about 30, 45s, and 60s. All these are multiples. You know, we'll still have 90, 180, 270, and 360. Okay? But it'll just be multiples of 45s, 30s, and 60s. Okay? So that's why we want to have that memorized at 45 and all that stuff. Okay? We've been through this already earlier. Sine is opposite. Let's do a different color here. That's where we got red and blue. Remember? Sine is opposite, which is always, remember, where's our theta always going to be? Down here by the origin, right? So opposite's always up and down, which is always the what? The y. Okay? If theta's back here by, in the, by the origin back here, adjacent's always going to be the x. There's adjacent. R is our what? Hypotenuse, right? And then tangent is opposite y. The y is always the opposite over x, the adjacent. Okay? Think about sine and cosine. I think we've talked about this already. If we were putting sine and cosine in alphabetical order, what comes first? cosine, right? So when we're thinking about a point has an x value and a y value on a graph, right? When we're thinking about cosine and sine, those are in alphabetical order also. Okay, so you see all these points they have labeled on the unit circle? Every blue one, every x value is what? The cosine. Every red one, every y value is the sine of that number of degrees or that radians. Okay? You don't have to look at this to figure all that out. All you have to do is draw a picture of the triangle. Andrew, pick one of these degrees, anywhere on it. Anyone you want.
315.
315, okay. So I'm going to draw this purple triangle at 315. So here's the 315 from this point. Okay. You see the purple triangle? Okay. What's the reference angle? Remember, this is 315. What's the reference angle? 45, right? Because I'm going all the way up to 360, right? Remember, the hypotenuse is always going to be what? 1. Okay, so when it's a 45, 45, 90, how do I get from hypotenuse to a side? Divide by square root of 2, right? And then when you rationalize it, you get radical 2 over 2, right? So, and we know that both sides are the same. Now, since I'm in the fourth quadrant, what's this y value? Negative. Okay, so that point is radical 2 over 2, comma, negative radical 2 over 2. See it right there? We just did that in the picture. Okay? Now, if I asked you for sine, you would do opposite over hypotenuse. So, Grace, what's negative radical 2 over 2 divided by 1? Same number, right? So the sine of that is negative radical 2 over 2. So you don't have to memorize all this to do this. Now, when you go to pre-calc, Mr. Hudson, he'll make you memorize it. I don't make you memorize it. I make you memorize those two triangles. And you can answer all those questions. Okay? Here it's just doing the same thing, talking about cosine and sine, alphabetical. All right? So, 225. What quadrant with 225 degrees is in standard position is the third quadrant. Everybody agree?
I do agree.
Right? So, if I draw my y and my x, okay, it's going to stop down here somewhere in the third quadrant. I always go back there for my x, for my right angle. What's the reference angle? What's the reference angle for 225? 45, right? It's 225 minus 180, right? To get this. What's this always? 1. What did we just learn? That we just did it. We divided by what? Right. So this is radical 2 over 2 when we rationalize. Now, since we're in the third quadrant, x is negative and y is negative, right? Because we're going left and we're going down. Everyone understand why those are negative? Okay? What are we looking for? Cosine, adjacent over hypotenuse. Okay? What is, again, Grace told us, what's anything divided by 1? Itself. So that's the answer to that. Didn't need a calculator, just drew a picture. It said use the unit circle, right? So we use the unit circle, but you know, some kids just want to look at this. 225 cosine is the blue one, the one that comes first in the alphabet. Okay, right there it is. But we don't need to look at that because we know the two triangles. We know how to draw the triangle in the right spot. Is this making sense? Olivia, you with me? When it's in radians, I just change it to degrees. What happens to the pies? Cancel. What's 3 into 18? I'm sorry, 6 into 18? 3. So what's 6 into 180? 30. What's 5 times 30? 150. What quadrant is my triangle going to be? Second. Very good. Guys are all over this. All right. So 150 is over here. In the second. What's the reference angle? 30. Remember 180 minus 150. Opposite the, well, that's a 1, right? So what's the relationship between the hypotenuse and the short leg? This is double, right? So what's double of 1? 1/2, right? Or divide by 2, right? What do you do to the short leg to get the long leg? Multiply by radical 3. What's 1 times radical 3? Radical 3. You just put it over 2 then, right? X value, though, is what over here? Negative. The mistake a lot of kids make is they'll get all this right, but they'll forget about negatives and positives. That X value is negative. We're looking for what? Tangent. Right? So tangent is opposite over adjacent. What do we do? Oops. What do we do when we divide by fractions? What's easier? Right. So I'm going to do 1/2 times negative 2 over radical 3. What happens to the 2? Cancel. So I get negative 1 over radical 3. That's right, but can I leave it that way? No, I have to rationalize again, right? So the answer is negative radical 3 over 3. Scott, that makes sense? Mm-hmm. Questions? So once you get your picture, you guys know exactly what to do, right? 350. Jack? Yeah, go ahead. All right. Fourth quadrant, right? What's the reference angle? Remember, all the way around is 360, and we went 315, so what's the difference? 45. Remember, hypotenuse is 1, and dividing by radical 2, and rationalizing. We already did this picture, didn't we? Remember the negative there. Sine, opposite over hypotenuse gives me what? Negative radical 2 over 2, right? Am I going too fast? Is this making sense to you? If you understand this stuff's going to be really easy for you. If you've been focused, which it seems like you are. Doing a good job today. Okay, 180. We call that a quadrantal angle. Because where is 180? On the line, yeah, it's on the axis. Okay? 180 would be from here to here, right? What point is that on the unit circle? What are the numbers for that? If it's a unit circle, how far is it from the center to the?
-1.
Yeah, -1. How far do we go up? 0. All right. Now's when you got to think about its cosine. Oh, sorry. I need an S, right? So this is where you got to think, what about alphabetical order? It's not asking for cosine, but the cosine is what? -1. The sine is what? 0. We got to remember tangent is opposite y over adjacent x, right? Remember, y is always the opposite side, right? From our reference angle. So my y value, 0, over my x value, -1. What's 0 divided by anything? 0. Okay? So those are kind of tricky because you can't draw the triangle because they're on the x or the y axis. You know, if we're talking 90, what's that point?
0,
Good. If we're at 0 or 360, we're at 1, 0. If we're at 270, we're at 0, -1, right? So those are the tricky ones. 90, 180, 270, 0, or 360. You use the 1, 0, 0, 1, -1, 0, or 0, -1, x and y coordinates of your point. You can't draw the picture. So those are the ones that stump people sometimes. Okay? What do we do? Pi. What's 3 into 180? What's 4 times 6? 24 out of 0, right? What quadrant's that? Third. Did we go too fast on that? So we're in the third quadrant. What's the reference? 240 minus 180. 60. 30. Hypotenuse is always 1. Opposite to 30 is 1/2. Opposite to 60, radical 3 over 2, right? Negative though. Both negative. Cosine is the x or adjacent over hypotenuse. So what's the answer? -1/2. Once you practice a little bit. This is just everything I've been showing you already. All right, they're talking about when sine and cosine and tangent's positive and negative and all that stuff. You can figure that out just by looking at the signs. 2 negatives make a positive. 1 negative, you got a negative, right? So they're doing, what's the reference angle here? Third, right? So I would finish off, that's my 1/2, that's my 1, that's my radical 3 over 2. Okay? They wanted all 3. What's the sign? Looking at the picture, what's sine? -1/2. Cosine? Radical 3 over 2. Tangent is negative 1/2 opposite, or y, over adjacent, or x. So we're going to do what? Multiply by the reciprocal. Okay, so we have to do a little work for tangent. Same stuff though, right? Good job today. Again, it's the same stuff. Here's your assignment. I even gave you time to do it, to work on it.